Hello all, welcome to part 9 of the Wireless LAN Security Mega Primer. In this video, we will look at hotspot based attacks. So why have we chosen hotspot? Well, based on all what we have learned, we are in a position currently to actually orchestrate this kind of an attack. So let's quickly go through some hotspot basics. Now, typically, a hotspot could be either free or paid and actually offers internet-based services in various public locations, such as coffee shops and airports. And I'm very sure all of us would have used at least one hotspot or more uh, in the last couple of years since they've been out there. So let's try and understand from a security perspective typically what hotspots have. Now, they have open authentication and MAC filtering is available at times. At the very same time, there is absolutely no encryption, simply because distribution of the web or encryption key is a nightmare when you want to have people sign on automatically. And at the very same time, there are other things such as, what happens if one person leaves the hotspot. Then all the keys for all participants would have to be reset, or else that one person could use the key and still get on or probably even distribute the same key to others. So it's a key management nightmare. At the very same time, hotspots use things like captive portals, in which, if you kind of remember, you will be presented with a simple login page in which you have to enter a username or a password or some kind of a passphrase, which you may receive over SMS or some other medium depending on what the hotspot is or where it is located. And once you've authenticated, it allows you access to all the network resources and even may connect you to the internet. So this is very simply put how hotspots actually work. Now, this is the typical case. There may be aberrations at times, but we will take up the typical case in our discussion. So, hotspot attacks. How can we orchestrate a hotspot attack? Now, picture this. Let's say the hotspot you're connecting to is SecurityTube right at the airport. And you're well aware that this is a hotspot available at the airport always, right? Now, what if I, as a attacker, come to the airport and start advertising the same SecurityTube SSID uh, using an access point which I've created using the alpha card? And this is exactly what we are going to do in this session, is how do you create a soft AP, a soft access point using your client card. Now, what is a soft AP? Well, a soft AP is an access point created entirely in software. And the power of this soft AP actually is that we can create it on demand anywhere and configure it absolutely to the last bit and byte. So as an example, what we will do is we can create an evil twin which would go ahead and broadcast the same SSID. So let's say the hotspot SSID is SecurityTube, then the attacker will also advertise SecurityTube. Now, as far as the attack itself is concerned, the BSSID or the access point MAC address for the real authorized access point as well as the fake one could be different. But to make things even more confusing for even advanced users, you could actually even set the BSSID to be same for both the access points. Now, how would all of this work? So let me take you to the next slide where I've created a very simple animation. Now, here is the authorized access point broadcasting an SSID SecurityTube, and we have a legitimate client which has connected to this access point, and we also have an attacker in the same RF vicinity. So what the attacker will do is he will advertise the same SSID SecurityTube, right? But the client is currently connected to the authorized access point. So the first thing he will do is send a deauthentication packet to break the connection between the client and the legitimate access point. Now, once this happens, this client will once again start trying to find the access point with SSID SecurityTube. Now, currently think about it from the client's perspective. There are two access points. One is the authorized one advertising SecurityTube, and the other is the attacker machine also advertising SecurityTube. So who would it connect to? Well, what happens is the client selects the access point which has the highest signal strength. And the reason is, well, more the signal strength, more is the available data rate and throughput of the system. And hence, if the attacker can actually broadcast, maybe with a directional antenna, towards the client at a very high signal strength, with the alpha card, as you may know, we can broadcast till up to 1 watt, then the client may end up connecting to the attacker machine, right? And when this happens, at this point, basically the attacker has access to the client machine. So the client may make a DHCP request and the attacker may run a DHCP server on his machine to provide an IP address to the client. Now after this, well, it's just Metasploit, Autopawn or some other simple attack tool to compromise the actual security of the client, right? So post attack, what are the different options? Well, one of course is once you have IP level connectivity, the attacker can fire penetration testing and vulnerability assessment tools and break into the client. Or there are two other options. One is he could relay all the traffic from the legitimate client back to the access point and conduct a man-in-the-middle attack. Or he could just relay the traffic to the internet depending on which machines or which hosts the client is trying to connect to, right? So we will take up these post-attack options in later videos. In this video, what we will do is we will set up the face access point. We will disconnect the client from the real access point, and then what we will actually do is we will go ahead and connect to the client using IP level connectivity. So this is what we are going to be doing in this exercise, right? So let the games begin. So this is my backtrack instance and my card is already up and running, right? And I have created a monitor mode interface. Now the first thing I have to do is locate the legitimate access point. So I can do that using airmon ng and hitting a arrow dump ng along with mon0. Now this already shows me the access point SecurityTube, if you notice here. Now what I need to do is bring up another access point also advertising SecurityTube. Now if you remember, I had two options. One is to have the same BSSID as the authorized access point, and of course I can also put it on the same channel or on different channels. Now in this case, let me put it on a different channel. So let me set the channel to channel 11. Now we are about to create an access point on channel 11. How do we do it? So there is a little utility which ships with the Aircrack NG suite of tools called Airbase NG. And this allows us to create an arbitrary access point on any channel and any BSSID, right? So if you notice, we can set the access point MAC address using the -a option. So what we will do is, let's use Airbase NG and set the BSSID to something arbitrary and impossible, which would be all A's. There should be 6 of them. And we will also set the ESSID. In this case, if you remember, it has to be SecurityTube. And then we give it the monitor mode interface on which to create this access point, which is mon0. Awesome. Now let me kind of step backward for 1 second and tell you what Airbase NG is doing. So Airbase NG is actually creating a soft access point on channel 11 for the ESSID security tube, and this access point has the BSSID all A's, right? So basically the whole software stack which is required for an access point is being created by the Airbase NG tool on the monitor mode interface. Now here is something interesting. When you take a normal access point, well, you actually know that there are two interfaces to it, right? So one is of course your little wireless interface which is accessible over wireless, and on the other side you have your actual wired interfaces, right? And the wireless interface has one MAC address and the wired interface has another MAC address. And the very same time, having different MAC addresses for wired and wireless also means there are two different network devices. So the first network device on an access point is of course the wireless interface, which has one MAC address, and the other is the wired side interface, which would have another MAC address, right? So in the case of Airbase NG, we just told you we created an access point, which means there have to be two interfaces, one wireless and the other wired. Now the wireless interface is actually residing on the Mon0 interface and has the MAC address all A's. So where is the wired interface? Now if you notice, there is a little message here saying created tap interface 80. So this is the equivalent of the wired side interface of the soft access point security tube created by Airbase NG. And we can verify that this is an actual virtual network device by quickly doing an ifconfig-a, and you would now see that 80 is also being listed as a available interface, right? Now by default the wired interface 80 is not really enabled, and we can very clearly see here that this is actually the case, right? So what we will need to do now is basically to go ahead and bring up this wired interface or the wired side interface, right? So we can simply do this by saying ifconfig 80 up, and now the interface is up. And now let's go ahead and do the following, is first actually connect the client to the authorized access point. So let's actually bring down our client here. And one of the important things you need to note is once you do this, the 80 interface also disappears. Keep that in mind. 80 is created contingent to the fact that actually an soft access point is created as well using Airbase NG. It will disappear the moment you remove that. So let me first connect to the authorized access point. And if you notice right now, we are connected to the access point, right? Let me kind of dim this a little bit so that you can see that the connection has actually happened. Now you see that. And one of the things which I've already done in the background is SecurityTube now is just an open authentication based access point, no encryption, no nothing on it. Let me just, well, I'll probably leave it to you. It's so trivial that it would not make sense going ahead and showing that to you. So create the access point. In my case, this is the actual physical access point which is there. And now what we are going to do is we are going to open up a new interface and then use air replay-ng to start a deauth attack. Now what we need to do is we need to deauthenticate all stations, and we of course will continue to use the monitor mode interface. One of the easiest ways to run this is actually just to kind of hit enter, and it'll quickly tell you what's missing, the BSSID. Note let's not give it the ESSID option. Why? Because if you give the ESSID, then Air Replay would try to find the corresponding BSSID, which may also include our soft AP's MAC address, right? Because this is also broadcasting the same ESSID. And hence, let's use the BSSID instead. So the BSSID of the access point, of the legitimate authorized access point, is this. Let's quickly copy it, add it here, paste it, and here we go. So it actually says, well, we are on channel 11 while the AP uses channel 1, right? Now this is a problem. The problem is because at one time the card can only be on one channel, right? Which is a big pain. So one solution would be to actually have two alpha cards. One you use for the deauth flood and the other to create the soft AP. So unfortunately, now we have no option but to actually put the card on channel 1, right? Here we go. And now we can start the deauth flood. So if you notice, the deauth flood has been started. And if I look at my client interface, you will actually notice it is unable to connect to this network, right? And the moment I hit a Control C, well, it should kind of very quickly connect back to SecurityTube. Okay. So now what we will do is we will bring up our Airbase NG system as well, and we will go ahead and start a deauth attack also at the same time, right? So this is ensuring that this is not going to be connected to the authorized access point. And now using the client card, you will notice the attack is still on, but the client is showing that it is connected. Why? Because it's actually connected to our access point. Beautiful. So the alpha card is pretty close, transmitting at 1 watt. And if you notice, even though we are doing a deauth attack on the authorized AP, the gullible client has actually connected to our soft access point, which is bringing up a simulated soft AP. Beautiful. So this deauth attack, well, what you could do is you could keep continuing it as well to ensure that the client can never connect back to the legitimate AP, right? Or you could just kind of stop it in between. It just depends. It just depends how actively the client is trying to connect back to various systems and things like that. Now, in our case, let the attack continue. There is no real harm in that. Or just as a quick example, if we kind of kill this attack, you would notice that the client still remains connected to our access point, right? So now let's do something more interesting. Let's go back here, and with this client connection, what can we do? Now, one of the things which we mentioned is that the client would make a DHCP request in all probability. But in this example, we'll not worry about that DHCP request and to create a DHCP server, etc. We'll do something a little bit more interesting. So let's start capturing on the various interfaces. In this case, what we want is to capture packets on the AT0 interface, because Mon0 is a bit crowded. A lot of stuff is going to be there. We only want packets which the access point and the client are exchanging. Okay. So here is what we are going to do. If you notice right now, Mon0 AT0 is not being shown here. And the simple reason is, if you remember, I told you that by default AT0 does not come up. So even though 80 is listed in the list of interfaces here on top, it isn't up by default. So we need to bring it up, 80 up. Now if we go back to Wireshark and start looking at the different interfaces available, you would actually see 80 appearing, right? So let's start the sniffing on 80. And if you notice, there are a lot of packets which the client is kind of sending, of which DHCP discover packets are there. Various ARP requests are also there, things like that. Now all we have to be is a little patient, just a little patient, right? And you will quickly notice what I mean. Let's be a little patient and just keep monitoring these packets. Right? Now, can you tell me what we are really looking for? Awesome, here it is, here it is, here it is. Here it is, my friends. So what happens? We have not supplied a DHCP based request to our Wi-Fi client, right? So what that means is the client keeps on sending these DHCP requests, and after some time, well, it's not receiving a reply, so it has to take an auto configuration IP address. This is the IP address in that whole 169.254.174 range, which many of us may relate when your DHCP does not work, right? And this is exactly what the client has done. And I can verify that by actually showing you the IP address on the client system. If you notice, this is the exact IP address which you're seeing on the iPhone as well as here, right? Gratuitous ARP packets are being sent to announce that this is the IP address the client has taken. Beautiful. Now here is what we are going to do. We are going to go back here, and I'm actually going to take an IP address in the same range as the client. So what I'm going to do is 80, let me assign an IP address, and let's say 169.254.174.227 was actually the iPhone's MAC address. Let me take up 226. Let me just quickly assign a net mask for the heck of it. And here we go. So now let's actually try pinging the iPhone and see whether it responds. Awesome, right? There are even duplicate packets and things like that, which is kind of very funny, but regardless. So here is what we are going to do. Well, by the way, this is an interesting find. I could probably use it to figure out something related to fingerprinting. Anyway, so we are now able to ping. Connection seems lost. Let me put my iPhone back on once again. The iPhone simply by connecting to it directly, right? Here it goes. Which means now we have IP level connectivity to the iPhone, which would actually mean that if there was an SSH service which could be running on this iPhone if it was jailbroken, right, I would be able to access it. And yes, actually my phone is jailbroken, and the password is not Alpine, which is the default password. It's been modified, and now I have broken into the phone. Awesome, right? Well, I wouldn't really say broken into the phone. I know the password, but if it was a general iPhone jailbroken by a non-tech dude who may have forgotten probably to change the default password for SSH, then yes, I could have broken in. But the fact remains that I can now run all of my Nmap and Metasploit tools to actually break in to this remote computer and do a further penetration test, right? So very interesting. Let's do a quick recap of what we did. The client was connected to the authorized access point. We continuously sent deauthentication packets based on BSSID to rip down this connection. In the meantime, on our attacker machine, we brought up an access point with the same ESSID but different BSSID. Because we only had one card and we wanted to do the deauth attack as well as bring up the access point, we had to do it on the same channel. So we also went on the same channel, which was channel 1. And then the client, because it was continuously getting deauthenticated to this access point, started searching for SecurityTube. And at that given time, what happened is that our signal strength was higher and the client ended up connecting to us. Now, instead of giving a DHCP based IP address to the client, we waited for the client to time out the whole DHCP process and get its own auto configuration IP address in the 169 range. The client got that and interestingly announced it. Now, one of the interesting things about the auto configuration IP address is that it actually can be used to connect to the client in the LAN. And what we did was we just monitored the air using the 80 interface and figured out what are the packets the client is sending. One of these packets also ended up being the Gratuitous R packet, where it actually announced its presence and its IP address, as we can clearly see here. With this, we figured out the IP address of the client. Then we created an IP address in the same range as the client and assigned it to the 80 interface. And after that, we had IP level connectivity to the client. In this case, I was able to SSH into the phone. Of course, nothing stops you from running your entire Nmap and Metasploit on that IP address. So this is how you can conduct a very simple attack on hotspot based clients. Now the advanced level of this hotspot attack is to the man in the middle attack, do transparent relaying, capture passwords and things like that, which we will take up in a subsequent video. I just wanted to break up the complexity of the problem into manageable chunks. So the first chunk is disconnect the client from the authorized access point, have it connect to you, right? Once it connects to you, you have IP layer connectivity which you can give to the client. And once that happens, well, any packet which the client is sending or the client is receiving is something you can scrutinize using the 80 interface. Well, that's all for this video. Hope you enjoyed it. Hope you're trying out all of these attacks. I've already seen a lot of comments where people have bought their cards and trying things out. Absolutely great. This is exactly what I wanted. So leave your comments behind, any questions, any doubts you may have, and I'll try my very best to answer. And that's it. See you. Bye-bye. See you in the next video. From a security perspective, typically what hotspots have. Now, they have open authentication and MAC filtering is available at times. At the very same time, there is absolutely no encryption, simply because distribution of the web or encryption key is a nightmare when you want to have people sign on automatically. And at the very same time, there are other things such as, what happens if one person leaves the hotspot, then all the keys for all participants would have to be reset, or else that one person could use the key and still get on or probably even distribute the same key to others. So it's a key management nightmare. At the very same time, hotspots use things like captive portals in which, if you kind of remember, you will be presented with a simple login page. Hello all, welcome to part 9 of the wireless LAN security mega primer. In this video, we will look at hotspot based attacks. So why have we chosen hotspot? Well, based on all what we have learned, we are in a position currently to actually orchestrate this kind of an attack. So let's quickly go through some hotspot basics. Now, typically, a hotspot could be either free or paid and actually offers internet-based services in various public locations, such as coffee shops and airports. And I'm very sure all of us would have used at least one hotspot or more uh, in the last couple of years since they've been out there. So let's try and understand attacker come to the airport and start advertising the same SecurityTube SSID uh, using an access point which I've created using the alpha card. And this is exactly what we are going to do in this session, is how do you create a soft AP, a soft access point using your client card. Now, what is a soft AP? Well, a soft AP is an access point created entirely in software. And the power of this soft AP actually is that we can create it on demand anywhere and configure it absolutely to the last bit and byte. So as an example, what we will do is we can create an evil twin which would go ahead and broadcast the same SSID. So let's say the hotspot SSID, in which you have to enter a username or a password or some kind of a passphrase which you may receive over SMS or some other medium depending on what the hotspot is or where it is located. And once you've authenticated, it allows you access to all the network resources and even may connect you to the internet. So this is very simply put how hotspots actually work. Now this is the typical case. There may be aberrations at times, but we will take up the typical case in our discussion. So hotspot attacks. How can we orchestrate a hotspot attack? Now picture this. Let's say the hotspot you're connecting to is SecurityTube right at the airport. And you're well aware that this is the hotspot available at the airport always, right? Now what if I, as a place SecurityTube, then the attacker will also advertise SecurityTube. Now, as far as the attack itself is concerned, the BSSID or the access point MAC address for the real authorized access point as well as the fake one could be different. But to make things even more confusing for even advanced users, you could actually even set the BSSID to be same for both the access points. Now, how would all of this work? So let me take you to the next slide where I've created a very simple animation. Now here is the authorized access point broadcasting an SSID SecurityTube, and we have a legitimate client which has connected to this access point, and we also have an attacker in the same RF vicinity. So what the attacker will do is he will advertise